and it's like,
So sorry.
it's okay.
I felt like I broke my neck this week. I cried so much.
I thought I was having a heart
No,
attack
I'm
in history class because I got a really sharp pain here and up and down my arm.
No, I thought I was dying.
I've had that
one.
I like
frozen.
Can I just tell you my next
Last
story?
year
I'm so sore I can barely walk up the stairs. Like I have to use the railing as my because I started fencing yesterday and I haven't done it for a while.
So at least you know why.
Yeah.
Well, the
Can I
next
tell you my
story,
next
and we gotta go on.
Okay, I'll tell you the next story. It was Tuesday morning.
Clean it.
I was fully prepared to come into school early because I was gonna finish my lab with Maria all morning. So I was gonna be at school by 7, like I was ready to be there. I was getting on a 6:09 train. I had my alarm set for 5:40. I was ready and I wake up and I'm like, my back and neck hurt really, really bad. So let me just, crack my neck and back really quick. Because I crack my body
People
all
do
the
that.
time.
I do that.
I do it all the time.
Don't do it around me, I'll faint.
I always crack my everything. So I wake up, I crack my back, I'm like, okay, that's good. So I crack my neck and I'm like going like this. And I was cracking it and I cracked it and it like I heard the crack. It was like a sharp, it was like a loud crack. But then all of a sudden, like my entire neck tightened up and if I tried to move it, it was like sharp shooting pains down my neck and shoulder. And I started like sobbing, like I could not move anything. It was like the worst pain I've ever felt in my life.
So what was it? Just a bad crick in your neck?
So I went to urgent care because my mom was so worried for me. She was like, because I've also been complaining about like my neck and back issues for a little while. I've been saying,
so she was
can
concerned.
I keep being like, take me to a chiropractor. So she was really, really concerned. So she said, go back in bed, like take like the heating pad and put it on your back. And then my dad took me to urgent care later that day, and like the urgent care doctor said that he was like, I don't want to order an X-ray just because I'm not going to. I don't think it's anything like that, but you definitely like pinched a nerve which caused muscle spasms in your neck and back.
That's happened to my back.
happens to me
I was
all the
rolling
time.
out with a
Muscle
tennis ball.
spasm.
Yeah, dude. I was rolling out with a tennis ball on the wall, and my back would just tense,
Tense,
and I
and
couldn't
it's like-
move. And I was like, it was at a volleyball tournament.
And then
it was
if you
so
try
bad.
to move, it's like the sharpest pain.
Yeah.
I feel
It's
like
like
if
a
you
muscle
move your
spasm.
neck really fast,
Yeah.
and like you,
It
that's
like
kind of
shoulders.
becomes
Yeah.
numb.
Okay,
And
so
they
Yeah,
put me on
so
muscle
like-
relaxers
sorry, we're
and
not
I
through.
they put me on muscle relaxers and I completely passed out all day and I woke up
That
at
will
like
knock
4.
you out. Yeah.
It was
But
crazy.
thank goodness for muscle relaxers.
It still hurts so bad. I can't.
Just like into the
Let's go.
I
sky.
can't move it like that.
Very, how's your foot doing?
So much better. Which makes no sense. So do not, I am not a good example of what to do. Like, you should not run a marathon in a sprained foot. And I should be like suffering the consequences of that, and you learn your lesson from me, like don't run while injured. However, I feel surprisingly good. So I'm just wearing flats for the rest of the week, because I got a marathon in a month. And I've just been biking and walking, but I'll start running soon. But I am being careful. Like I went super slow.
I could never run.
Do you ever
Marathon
bike to
is
school?
so long.
Do you ever bike to
So
What?
long.
You ever bike to school?
Anya's like 3.5 miles.
How city bike maybe.
Yeah.
Yesterday I did track practice. I
Like a
ran
little
maybe
skirt.
not
Yeah,
even 4 miles. I thought I was gonna die.
But I bike
But a
home
marathon.
some, 'cause
Yeah.
I've changed.
26
my
miles.
There's
I
just
walk
like
out
by
the stairs
second,
and I
there's
think
just
I'm
like
gonna
not a
die.
lot of the city bike things.
Yeah.
I feel like there's
Well,
one
how long
outside.
ago from park?
We run 2
Yeah.
laps
We
around
took
the
the
tennis
elevator
court.
for
We
free.
think we're
Roughly
gonna
8.5
die.
miles.
Yeah.
I'm sorry,
Really,
84th and
God,
Arch,
we did
and
two
then I have
tracks
to
after
park.
literally
She's
2
like,
laps.
"Hey,
I
Maybe
was
some
like,
are taken, some are Okay, so
Sorry,
anyway,
can I just say we were running outside girls, we were like running marathons. I can't run a marathon.
How'd you think of to keep going?
I'll try to remember, I'm just done it for so long, I'm sorry, I don't know. But that is an issue, when you hit mile like 12 and you still know in your head you have 14 more to go, and then you
Yeah.
hit mile 14.
I'll be like,
That's the hardest stretch, like 13, you think people that run half marathons now still got half more to go. That mental getting over to like mile 17, that is really tough.
You can
Um,
think of recipes
so-
or something.
I've
listen
seen
to
Christmas
music?
carols.
I think that's what I'm gonna eat.
You do have to just do mindless stuff.
Yeah, I like when I have to run, I have to like I just think about like what I want, what like my last meal would be,
I tried to
and then
Really?
That's
That's
terrible.
I feel like I would count my
Yeah.
steps. I feel like I would count my
I would
steps.
not.
Well, also in training, you've done all of that. So I sort of like in basketball or volleyball, when you've already faced that, like that final few minutes of a game when you're exhausted, you've kind of already done all of that. So anyway,
So I have a question about, it's really quick, but just like,
Last
I've always
question.
been curious, like when you're training for a marathon, do you run like full, like 26, or do you
hardly
split it up?
anybody does. It's not
Okay.
very recommended.
So like when you are running
People
that,
run anywhere from like, it's good to run anywhere you're long as
So it's like-
15 to 20 miles.
if it's like your first
I
marathon,
always
then
do
that's
it
your
from-
first time running 26 miles.
Most people, because you wear your
Yeah.
body out. It
Yeah.
takes weeks to recover. So even the 22 to 24 is usually for most people not a good idea.
Do you just not feel your
Because your
legs
body
and-
starts to burn muscle. And the recovery's just not worth it if you have a marathon coming.
Is that why runners
Also, if I
usually
run
really
26 miles, I want people cheering me on and I want like a medal at the end.
Yeah.
I probably have done it. I got lost one time on a 20 miler and I have no idea how far I ran or if I would ever come back out of the stupid trails I was on. When I was in the middle of the city, I'm like, I can't get out.
The furthest
No,
I've run
26
is
miles
1 mile.
is so long. I saw you yesterday, and I literally ran 3.5 miles, and I thought I was gonna die.
That's a long way.
And that was my first time ever running. 3
That's
miles.
when someone gets like
As I was running, I was like,
That took so
After I started walking.
Girls, I'll try to remember it in quick time, so in case you want to watch the class notes, it'll start here, okay? But so far, all of this has been recorded.
That's so
Okay,
funny.
so anyway, what will happen, you should not be here yet, so don't worry. It would be like if I was your second or third grade teacher and I go 5 times 4 and you're supposed to say 20. You'd be in a panic because you're still at home doing your flashcards and looking at your little chart, okay? But the day came that you were like 5 times 4 is 20, okay? The day's gonna come where that's gonna be like 1 plus 2 is 3. So the cosine of 120, cosine of 60, you should have gotten 1/2. Did y'all get 1/2? Secant of 30 would take anybody a little bit of time because first you got to find cosine of 30 and flip it over. All right, so let me pause for a minute. This is where you should be right now, probably looking at your memo page, or if I gave you this as a quiz, you'd probably go, can I write my charts down? So let's write them from memory. So I have sine, cosine, tangent. So suppose you're on a quiz and you want the extra like Band-Aid or insurance policy of just actually seeing your chart instead of seeing it in your head until you've memorized it. The thing that I don't care if you write it down is I realize every time you write it down, you're probably that much closer to memorizing it. I had a student in honors pre-calc, because we're somewhat ahead there, that said, I don't even grade my quiz because I didn't go 1, 2, 3, I went 3, 2, 1. Okay, and then, because they went 3, 2, 1, 1, 2, 3, 3, 1, 3, or whatever.
No.
And that'll mess up a lot of stuff. So I don't think I've said this to y'all.
Yeah.
Start low. Okay, so if you're looking at a chart going, oh my gosh, I don't remember if it's 1, 2, 3 or 3, 2, 1. You heard my voice go start low. So it's 1, 2, 3, 3, 4, 5. It doesn't go 6, 4, 5, 3. It's 3, 4, 5. 3, 4, 5, 6. Another thing on your new chart that I was throwing at you with 13 seconds left in class, your 0, 1, I call it the IOU chart, but you really start with all the zeros, okay? So anyway, you'll be able to write on anything you want to all year for me or for this rest of the semester into next semester. You can write this down if you want to, 3, 4, 5, 6. Start low, 1, 2, 3, 3, 2, 1, 3, 1, 3, 3. First 2 columns are divided by a 2. And everything I gave you on your worksheet was in the first quadrant. Today we will leave the first quadrant, okay? Then if you also wanted your quadrantal angles, you would go sine, cosine, tangent. Our book actually has somehow all of this in one chart, I think. But the book actually uses charts, the book that we have, instead of what's called the unit circle. I will show you the unit circle probably today. Start low. Do not start that at 90, because if you do, everything will be off. And I'm having to guess where I'm writing right now when I get this far over on the board. But it goes 0. Let me try to guess again. IOU. Whoa, that's not good. Are you serious? Okay. So, where am I?
0, 1, 0.
Yeah, no, I mean like on this board. I'm trying to guess where I'm writing. 0, 1, 0, I, O, U. Don't ever actually write down U on a piece of paper. Write undefined. It's just a cutesy way to remember it. And then a 0, 1, 0, I, O, U. And the last two ones are negative. And then you can just refer to it. There's all this stuff that we will worry about later. Reference angles and coterminal that I taught you kind of the first day of trig. So anyway, now we're at secant 30. So then you also need to know secant's a reciprocal of cosine, which is also on your memo page, okay? So secant's a reciprocal of cosine, so I'm looking up the cosine of 30, and then I'm gonna flip it over and get 2 over root 3. On Delta Math, you'll have to do that 2 root 3 over 3. But for homework checks and just quizzes that you're doing for me, you can leave the square root on the bottom. But for Delta Math, which you have some to do for homework, and the quiz might be on Delta Math, I haven't decided, you have to rationalize. Nazareth?
I got confused because I thought that cosecant was the reciprocal of cosine.
No. Look at your memo page and see if you have it right. Secant is a reciprocal of cosine. Cosecant's a reciprocal of sine. Do you have that on your memo page correctly?
Yeah.
Okay. So one of the great things about homework and practice and anything that we do like that, you know that from musicals and plays and drawing and everything, is that it's not so bad to mess up when you try. It just makes the lesson that much more meaningful. So secant's a reciprocal of cosine. Cosecant's a reciprocal of sine. Tangent and cotangent are the ones that are kind of easy to remember. Okay, so anyway, cotangent of 30. All right, I'm going to look up the tangent of 30, which is square root of 3 over 3. You may have written 3 over square root of 3, but if you rationalize that, it just becomes square root of 3, which I spent a fair amount of time on at the end of the last class. You will see even myself rationalizing in that case. Whereas I might leave 5 over square root of 3 because there's no point in rationalizing it to me. But I probably wouldn't leave 5 over square root of 5 because that becomes just square root of 5. It's the exact same number. Are we okay on 1, 2, and 3 so far? Everybody checking? All right, because you want this sheet to be able to study by. Cotangent of 45 is 1. Cotangent is reciprocal of tangent. Cosine of 180, you get -1. Now let me pause right now and show you where all this stuff comes from. I was like, oh my gosh, you're going to need it for worksheet 1.5, which is kind of hysterical that it became a 1.5 worksheet in my computer years ago. But it's because something happened in teaching pre-cal one day that happened to us where I wasn't quite ready for worksheet 2. But all of a sudden I realized worksheet 1.5 had those quadrantal angles on them where you don't have a reference angle. Okay, so watch this animation. It has creepy music, I don't know why. It's very dramatic, it's not creepy. Oh, well, you can't even hear it. It's kind of aggravating. Okay, so I'm gonna turn it off. All right.
I like it.
Well, we're going to do without it right now because I want you focusing on what's happening here. All right, this is sine. So what you're supposed to see is the opposite and the hypotenuse. The opposite side is red and the hypotenuse is black. Sorry, the opposite side is red. It'll go backwards, which I'm not sure what that does. But do y'all see the triangles that are made with the bow tie butterfly that we talked about? Okay. All right, so all of a sudden, did y'all see that triangle just got smished?
Yeah.
Okay. And so then what in the world are you going to do with without opposite, adjacent, and hypotenuse if all you know is SOHCAHTOA? All right, so let's just pause for a minute, and this is like a teaching moment. At 30 degrees, let me move over where this is working. All right, at 30 degrees, you don't write this on your memo page, okay? We'll write something on your memo page in a minute. At 30 degrees, The opposite side is always what we call your y component. The adjacent side is always your x component, and the hypotenuse is always the radius of this circle that you're going around. Now honestly, that angle looks a little bit more like 45, doesn't it? Alright, so, but I don't care, whatever the angle is, when you swing around and find your reference angle, like the first homework I gave you, do you see how the angle's gonna be right here? And it creates one of our special triangles. Opposite is y, adjacent is x, and the hypotenuse is the radius of the circle. Do y'all see what's coming in worksheet 2 after worksheet 1.5 is everything so far has been in the first quadrant where x is positive, y is positive, and the radius is positive. What's gonna happen is, you see you might have some negatives. Now it feels funny to have, you never had negative ratios before for 30, 60, 90 triangles, but you gotta, physics and calculus is about the study of, Cal 1 is about rates of motion, like velocity. And if you've been in any physics, you might have done a vector and forces, and if you haven't done that, you will. And that positive and negative mean a lot, don't they? Okay, which way you're pushing, which way you're going. So if I say that I am going with a velocity of 30 miles an hour as opposed to a velocity of negative 30 miles an hour, one indicates that I'm going up, the other one indicates that I'm going down. Or it indicates that I went to the right, and then I can tell you how I've gone to the left. So all of that's coming, okay girls? Do y'all see x and y can be positives and negatives? I'm going to tell you while I'm on this little part right here, and then we'll write something down. The rules are that the radius is always positive though, as this moves around and creates all these bow ties that we've talked about, all these different triangles where you might need your reference angle. I intentionally just drew 4 that do not have the same reference angle, okay? But my point is, once you land on what I call the terminal side, you have this reference angle, and all you know right now is to do opposite over hypotenuse. I don't know why I put those marks there. Opposite over hypotenuse, I guess I could have put arrows. Opposite over hypotenuse or adjacent over hypotenuse or whatever. Your x and y components, do you see x and y could both be negative?
Yeah.
And this feels funny, but r is always positive, okay? X and y will carry the sign of positive or negative. R is always positive. The reason R is always positive is what in the world would you do if you came in here for class, and I started on time, first of all, that would be shocking. But second of all, if I said, okay, before we start, I want everybody to draw me a circle with a radius of -8.
Oh.
You couldn't do that, could you? You would need to draw a circle with a radius of 8. A radius is a distance, like the hand on a clock.
Yeah.
All right? But as that hand moves, you see how it might go into the 4th quadrant where x or y, where y is negative. It might go into the 2nd quadrant where x is negative. But that radius is however long that red hand is. So just keep that in mind. R is always positive, and I told you why, okay? X and Y will carry some signs. Now, as you just saw so watch my arms. So here goes an angle. Okay, so this is 0 for y'all, right? So here goes an angle. And what I want you to imagine for a minute is my y coordinate as my angle gets bigger, okay? R isn't changing. That radius is just sweeping around creating angles, whatever the radius is. By the way, most teachers around here teach what's called the unit circle that I've talked about and that you'll hear your friends using, okay? If you understand that you're studying with a friend, I don't change what you're doing. You can pick and choose whichever you want. I would only teach you what I feel like is the easiest, most understandable way though, because I'm your biggest cheerleader, okay? One big reason I don't use the unit circle is because you see me constantly go, well, what if the hypotenuse is 8, then the short side is 4? They spend a lot of time just saying the hypotenuse is always 1, and it really confuses people more than it helps them. There's a reason that somebody teaches the unit circle. All that means is they're dealing with a circle whose radius is 1. Let me go ahead and say why. If you deal with a circle that the radius is always 1, if this is 1, the short side is half of that, and the long side is square root of 3 times the short side. And so do you see if you use a radius of 1, it gets you all the numbers in your chart? What I would rather you know though is that radius could be 100 miles out into space, because people use a lot of trigonometry in space and flying an airplane or building something. If this is 100, sorry, it's not writing where I want to. If that's 100, then this is 50, and it's still a 1-to-2 ratio. Okay? The reason people use a unit circle is that all these numbers appear around the edge. Any questions before I go on? Okay, so back to what I was saying about watching my arm. So if you could imagine this, and right now I'm going to take this arm, and this is the Y. Would y'all agree that's my Y coordinate?
Yeah.
So what should the sign of 90 be? For a split second,
0.
usually, wait, hang on. Usually Y is less than R, isn't it? Because what is R? The what of the triangle? The hypotenuse of the triangle. And y'all see how X and Y are smaller than R because of what we learned in geometry about hypotenuse?
Yeah.
Okay? But watch this Y side. I mean, you've got to kind of imagine that it's coming up from underneath this axis, okay? So here comes my Y coordinate. And here I am at like 80 degrees. Y and R are almost the same size, aren't they?
Yeah.
But what happens right up at 90?
1.
For a split second, they become the same thing, and then it starts to go down and Y starts to shrink again. Do y'all see what I mean? What in the world is Y?
So it's 1. It's 'cause
Sign
it's
of
like
90
over
is 1, okay? Because just for a second, for one moment in time, they become the same, and then the Y starts to shrink again.
Oh.
So what is the sign of 0?
0.
There is no Y coordinate. That's ridiculous. Do y'all see what I mean? Why is the cosine of 0 1? What is cosine is adjacent over hypotenuse, which is your x coordinate, okay? Right now, isn't my x coordinate the same as my radius?
Oh, so it's at 1.
Okay, so now x is going to be between my elbows, okay? Y'all see x is right here. All right, so what happens to cosine as I get closer to 90? It gets smaller until, oh no, I don't even have an x for a minute. So the cosine of 90 is 0. All right, now that's sort of a silly way to explain it. So let's look at the animation again. Silly, but I'm in control of it. I don't know what GeoGebra does here. I don't think I'm going to do it. Let's see.
GeoGebra takes me back to 8th grade in this
Yeah.
Oh wait, no, Miss Bader, GeoGebra. Where is she? Who was Bader? I had her in 6th grade, I think. She went to the upper school, I thought.
Okay, this is great. Watch. All right, this is awesome. All right, so your eyes are focused right now on sine. I don't care about this conglomeration of stuff over there. Okay, so we're looking at this. And let's just look at sine for a minute. Get in your mind what the opposite side would be. Do you see how the opposite side is shrinking
It's
and then
not
it
out
just
there.
slammed into 0?
Now it's there.
Okay? And now, so the sine, the opposite over hypotenuse, doesn't even exist at 0 and 180. But what happens at 90?
They're 1.
And what happens at 270?
They're also at 1.
But what kind of 1 would that be?
Negative.
Negative 1. Okay, because it has a direction. Now let's imagine cosine for a minute. Cosine is adjacent over hypotenuse.
Now it's 1.
All right,
It's
so
negative
now,
1.
now you're looking, okay, 0. What's the adjacent?
1.
Do y'all see what Bryn's saying? Do y'all see that? Okay. If you don't see it,
0.
let's just watch for a minute and don't say anything. So thank you, or I'll get everybody to say something in a second. You're watching this adjacent side right there. Okay?
Can I go to the
Do
bathroom?
you
when
see
Kate
for a
gets
split second? Do you want to go to the bathroom? Is that what she said?
back? When she gets back, when Kate gets
Yeah.
Do you have to go on here?
Yeah, I do.
No.
You could have just said it.
I did.
Okay.
Didn't.
With my body language.
So with your body language.
I'm going after Kate.
Where's
All
the
right.
bathroom?
So look at this.
I'm going after she gets out. That's illegal for 2 people to go.
Apparently it's illegal. Okay.
For legal purposes, it cannot be.
All right.
Well, you could just tell me with your words. You don't need to tell me with body language.
Well, sometimes I'm too tired to use my words.
Okay. Well, it's a good thing that I can read your body language too.
Thanks, Brenda.
All right,
Have a
well,
fun time at the bathroom after cake.
for some reason, we're talking in a
Well,
British
yeah.
accent, which I can't do.
So we're not performing illegal
Let's
activity.
go on.
He tried.
All right, do y'all see that this is opposite, this is adjacent, and this is hypotenuse?
Yeah.
All right, what I'm moving you toward, though, is that's not really all that awesome if you totally lose the opposite or the adjacent, then what in the world are you gonna do, okay? So we start to call this X and Y and R. Do y'all agree that's X, Y, and R?
Yes.
Okay? Now that's probably about 80 degrees. You can see that this Y component is not quite as long as the radius, but it's getting really close to a 1-to-1 ratio. What's happening to my X? What's been happening from 0 to 90 to my X? It's been shrinking, hasn't it? Do y'all see what I mean? What's happening to my X is I start way over here.
It gets smaller.
My Y starts small and my X starts big, okay? Till I get up to 90. What happens at that? That's like 89 degrees right there, okay?
But then so at 45.
But at 90, that X value is actually 0. Like this dot up here would be like 0.4 or whatever the radius is. Do y'all see what I mean?
Yeah.
There is no X component, there's only a Y component. And then doesn't all the same stuff just repeat over and over again? Which component do you lose at 180? This was your Y component, it smashes your Y component.
Yeah, you lose your Y.
And hasn't your X been growing?
Yeah.
Okay?
Oops, I thought X disappeared because
So then at certain
The
times.
X
always-
disappears at 90 and 270.
So
Do
you
see
always
that,
have the
Ava?
hypotenuse. It's just
Watch
a
my
question of
X.
whether.
See my X?
yeah.
Watch this X. That's the X right here. So this was the X,
Okay.
this was the X, this was the X, this was the X, until I get up to 90 and the X just got squished,
That's a 5 right
okay?
That's fun.
All right, so let's move on. So, let me go back to that slide I've been working on where we just sort of paused in the middle of everything because today I needed to make sure I teach you where in the world this came from over here. I don't use the IOU chart. You're welcome to. I didn't learn it until probably 10 years into my teaching where one of my students in Memphis was like, oh, wait, what about moving longer than 10? Anyway, oh, I found this great chart. And I'm like, no, I want people to understand it, but I'll show you and everybody like the chart, okay? The chart is extra insurance, but I understand it. Where I'm thinking cosine of 180, okay? I realize that my Y component at 180 has just been smashed. And I know my X component is the same as my radius. I'll show you all of that, okay? So make sure you're watching. So let's go on to another slide as long as I've gotten this far into it. And we'll go back to your worksheet. All right, so we'll go up here. All right, so what we're gonna see now is that as we're moving around and we find a reference angle, which is always 1 to the closest x-axis, we have an X, a Y, and an R component, okay? It doesn't matter where I land. I'm basing this on X, Y, and R. So I'm not using opposite, adjacent, and hypotenuse anymore. So once again, right here, okay, isn't X the adjacent side, Y is the opposite side, and R is the hypotenuse. So I'm going to focus on this. X is adjacent, Y is opposite, R is hypotenuse. Isn't Y always the opposite side of the angle we're looking at? So I don't know. I don't think you've written this on your memo page yet. So this is, have it out. Don't write anything yet. I'm going to move you away from SOHCAHTOA and into trigonometry. Sine, cosine, and tangent. Let's go back to what Nazareth was asking me earlier. I'm not going to write secant, cosecant, and cotangent because if you can find sine, can't you find cosecant?
Yeah.
If you can find cosine, you can find secant. Okay, so I'm just going to write these 3. If you need the others, you can flip them over. Reciprocal? Okay. Sine is always, watch this, opposite over hypotenuse. So it's always gonna be y over r. This is very free, by the way, okay? Cosine is x over r, and what is tangent? Opposite over adjacent. Opposite over adjacent, what would that be? Always it's gonna be y over x, right?
Oh, X.
Do you see how opposite over adjacent?
Yeah.
All right, now I'm gonna box this in. It doesn't really have a name. Do you already have that on your memo page?
Yeah, but I had it written.
Okay, so that's what that means. I must have explained it to you once before, but we're gonna actually use it now. If you don't have that on your memo page, get it on there.
I
Everybody?
think maybe it was the
thing
end
in
of
the
the
box.
class.
Yeah.
Probably.
It was.
No one
You're
really.
like-
I'm probably like, wait, I'll do it later or something, but.
That was so vulnerable.
I think we do.
I think most people have it, okay?
I love you that.
All right, now, let's move on with that. So what happens is if I want to find all of a sudden the sine of 90, it's not like the sine of 60 where I can do this. Here's 60. That's not 60. Say I want the sine,
Is there, I like her pants.
Thank
Me
you.
too.
They're so
I
snazzy.
like the
I like your belt.
I just like everything but my shoes, but that will change next week. Okay. Sine of 90, yeah, they're just fake Doc Martens because I can afford them when I need flats. All right, so I'm talking about sine of 60 for just a minute. And you're not writing on your memo page, by the way. All right, so 60 degrees. What you've done so far is you've thought through opposite over hypotenuse or adjacent. But at 90, I think we'd all agree that's not very helpful. It's also not helpful that this board is never oriented. But anyway, at 90 degrees, that's a 90-degree angle. It's not like a 70-degree angle. I don't even have any I don't have any opposite, adjacent, and hypotenuse. So watch this kind of once and for all. So what if I have a circle with a radius of 7? How will I know what the sine of 90 degrees is? The sine of 90 degrees, let me go toward 90 degrees. I'm going to color in purple my y component. Sine's getting bigger and bigger and bigger. If you got out your calculator and punched in sine of 30, sine of 60, sine of 70, sine of 80, sine of 85, sine would be getting bigger and bigger. Because y'all see y is growing, but r is not. R is the same. Okay? But what in the world happens at 90? If the radius is 7, what is the y component at that split second? If the radius is 7, this is getting closer and closer and closer to 7 until that split second. It is 7, isn't it? What's 7 over 7? 1. What's in your chart for sine of 90? 1. What happened to your x component, which will be in yellow?
0.
Yes. Was that Ava's voice?
Yeah.
Your x component has been shrinking till it disappears for just a second. What is cosine of 90 in your chart? In your IOU chart? 0.
So
Do
like
y'all
this-
see why? That's how we know all of this,
So
okay?
the sine, the cosine, and the tangent, they all represent just like one side of the triangle though, right? Or was that
Sine
like in
is,
a way?
oh no, I'm saying y over r.
Oh, okay.
That's like a 1-to-2 ratio. Y over r, that might be more like a 3-to-4 ratio.
Okay.
This y over r is getting even closer, but right then my y is my r.
Okay.
So right here, girls, sine is y over r, cosine is x over r, tangent is y over x. So let's do 270 and then move on.
All the ones that were like not on the chart were hard.
Yeah.
I don't think
I just guessed.
All right,
I
so
was
we'll get to
confused.
that.
I
All
was
right.
Oh, isn't it
but
just
it
the?
didn't make sense.
It's just the
Hang on, let me
What's it
keep
do?
going, just because we talked so much at the beginning. I'll keep going, and then if y'all still have questions, I'll get to those. If I want to know the sine, the cosine, and the tangent of 270, this is how I do it. I think around to 270, all of a sudden, like if I'd land at 240, wouldn't I have a reference angle that I could use, okay? But if I land at 270, I don't even have a triangle or a reference angle. But I realize that if this is a circle with a radius of, let's say, 3, this point would be 3, 0. What would this point be? 0, 3. This point? Negative 3, 0. And this point? 0, negative 3. And we've established up here that sine is y over r. I don't need opposite and adjacent anymore, or hypotenuse. Look down here. Sine is y over r. What's 3? I'm sorry, my writing's so hard to read. That's negative 3 over 3. Do y'all see how that's pointing down 3? And what's the radius? 3. Do y'all see my y component here is negative 3? All right, so I'm putting y over r, and I get negative 1. What does this say cosine of 270? Cosine of 270, bam, is x over r. X over r is going to be 0. And what's the tangent of 270? Y over x. What's y over x? What is zeros on the bottom? What do we call that?
Undefined.
Undefined. And do you see how it matches what's in your chart? So that's how I got all those numbers in your chart. I agree that most of you will still use your chart instead of reasoning, but that's why that happens, okay? You've got to really get set in your mind over the next few days, only because it will help you, is that cosine's like x. Cosine's this adjacent side. So you can really think about what x is doing. Sine is like y. Isn't sine like the opposite side? Sure, the hypotenuse comes into play, but it's not the thing changing. Cosine's like x, sine is like y. It's in alphabetical order if you forget, but I've drawn you so many pictures. If you ever forget, you could draw your own picture and realize this is x and y and r, opposite over hypotenuse.
Yeah.
Which comes first in the alphabet, cosine or sine?
Cosine.
What comes first in the alphabet, x or y?
Okay.
X.
Took
Cosine
Yeah.
is at the end, I have to start at the beginning. But y'all see what I mean?
Yeah.
Okay,
How
so
do you know the radius?
it doesn't matter, that's what I keep trying to show you.
Oh.
So say I didn't know, that's why a lot of teachers just keep using 1.
Yeah.
But because it doesn't matter if it's 1 or 85 or 3.
Okay.
Like, Kate, if I do 1, the point of all of this is that's the beauty of trig is you realize there's tons of people might be doing this in a building across the street, or they might be trying to figure out an angle to project to land on the moon in outer space.
Okay.
And if their trig is off,
Yeah.
there's horrible stories of them losing millions of dollars of equipment because something went wrong
Okay.
with their calculation.
And that is where,
And
what's
so-
her name comes in.
Hidden Figures lady. Yeah.
Yes, she was awesome.
What was her name?
I need to look up that quote, but that's one of my all-time favorite quotes when he said he was trusting her, like the
Oh, the
astronaut.
If
Yeah,
you can get
yeah,
Oh, yeah.
yeah, it gives me goosebumps.
Wait,
So
what is it?
anyway,
Yeah, it's like if she does the math.
let's go
if
back
she's
to
the
what
one that does the
Kate
math.
was asking.
Wait, what?
It doesn't matter what the radius is, all right?
Okay.
So if I have a radius here, this point, try to get used to what I'm gonna write. Let's say if this was 5, wouldn't this point be 5, 0?
Yeah.
If the radius is 5,
Yeah.
that point, these are funny points out here, okay?
Yeah.
You would need to find them. Anyway, this is 5, 0. What would this one be?
0, 5.
0, 5. This one would be negative 5, 0. This one would be 0, negative 5, okay? So let's do tan of 270.
Okay.
Y
and
over
that just
x.
means that the
It's
R
still
is
undefined. I used a radius of 3 and I used a radius of 5. What about the sine of 270? Sine is y over r.
Yeah.
I got negative 1 either way. So it doesn't matter how big the radius is. You can count on this.
And you know which numbers to use at the bottom, like and what do you use the 0, 5 or the 0, negative 5 based on which
X
quadrant
and
it
Y
is?
and R. They're not in a quadrant. That's a great question. These are called quadrantal angles, which
Yeah.
to me I feel like they should be called non-quadrantal angles because they don't land in a quadrant, but they're called quadrantal angles.
Okay.
They're not in a quadrant.
Yeah.
you're on the right track though. Later on, today or next class, I gotta deal with what happens. All I've done is first quadrant and B so far. I'm gonna flesh out more of Kate's question though. If this is R, I would argue this is counting out R and going up none. This is counting out none on the x-axis and going up R units for this circle. This point would be negative R, 0. This point would be 0, negative R. And this point would be R, 0. That's a negative R.
Okay.
Do y'all see where I am with this?
Yes.
Okay, so if I want the sine of 90 degrees, I've tried to establish that sine is always y over the radius. What is your y component?
R.
And what's the radius? R. What's sine of 90 in your chart? 1. Okay? You're welcome to use your chart, your IOU chart, to bail out of this. But I think it's real important you understand where that chart came from.
Yeah.
You know, I didn't just throw the 1, 2, 3 chart at you. I kept doing 30, 60, 90 triangles till I just wouldn't want to do them anymore. And why am I reinventing the wheel when I can just throw it in the chart? The 30, 60, 90 triangles are not going to change. These ratios are not going to change. Okay? So, so now let's go back to your homework sheet and go over the rest of the answers.
We're on number 6.
Thanks. All right, so I'm going to kind of go fast. And just, I'll pause, and if you have a question, let me know. Tangent of 90 is undefined. And you better write at least that much for me, don't just put a U, okay? I can't let you go forward in life doing that. Cosine of 0 is 1. Secant of 90, that one's tricky.
Undefined.
Why? Good.
Because if you reversed it, it'd be 1 over 0.
Okay, let me say this. I didn't say it. I just sort of left y'all to your own devices here. That's very good. The reciprocal of 0 would put 0 on the bottom, which would make it undefined. So therefore, if you get undefined, what's the reciprocal of that?
Undefined.
Undefined reciprocal would be what?
1.
Hang on.
Oh, gross.
0 over 1.
No.
Wait, so
Undefined
undefined.
Yes, you're right. You're probably right.
No, because that means that it would be cos.
Don't we say things are undefined in these scenarios?
Yes.
Oh, would it be
So if you take the reciprocal of that, you get 0. Undefined, what in your experience, like this gave you a hole in the graph. Look at how this math is going to merge together, okay? What has this made on your graph? If you got 5 over 0 when you were doing all your first tests, that would give you a what asymptote? Vertical asymptote, and your graph went off to where? If I have a vertical asymptote, when I got a number over 0, do you remember my graph would go off to where? Infinity. Okay? Something over 0 means it's undefined because it's gone off to infinity, which blows our minds, and we don't understand that, okay? That means I would have everything. Is it possible for me to have everything? As soon as I acquire it, you would hand me like an acorn, and then I would have, I don't know where I got that from, that's really
You would hand me an acorn. Does anyone here have an acorn?
You would
Well,
so
hand me an
many-
acorn.
Well, that's what you're saying.
What we don't know for well, hand me an acorn. I'm stumped.
How about $1? Anyway, you would go, you don't have anything, everything weight. But then you'd be standing there, so I don't have whatever you have. I don't have your earrings. Do y'all see what I mean? It's gonna, but what's the reciprocal of having everything? I don't have anything, which is 0, right?
Yes.
So do you see how that makes sense?
Yeah.
Okay.
So the answer
So
to that one
the
is 0?
reciprocal, hang on. The
Also, the
reciprocal
reciprocal
of 0 is undefined. The reciprocal of undefined is 0.
Oh yeah, but it's also
Wait,
like
but then so
like
secant of 90
secant of 90 is just the opposite of cos of 90, and cos of 90 on the IOU chart is 0.
It's 0, so this would be undefined.
Yeah.
So y'all figured that out, okay? Cotangent of 0 is 0. No.
Undefined. It's
Undefined.
So
Because
reciprocal of
girls,
undefined
stop
is
looking at
0.
each other, and that's gonna be on the video. If you're teaching them what to say. These girls over here, and maybe I think these girls over here are learning. These girls are not.
Kate tried to tickle me.
And then Anya punched my elbow.
And I
Girls,
teach 11th grade in New York City. Okay.
This is on YouTube though.
Don't punch
You're like,
me.
welcome to math class.
In New York
Where
City.
Anya
to
tickles
someone
people
who's
and
like
Kate
going through the
punches
depths of YouTube one day and like
No,
finds
it
all of
was
our
Kate
videos.
punched Anya and Anya punched Kate in the weekend.
My Memphis students, we go, what is happening in New York City? All right, so anyway.
Hi guys.
Hey girls.
Welcome back to my YouTube channel.
Thank you.
Don't forget to like and subscribe.
Bryn.
Smash that subscribe button.
Alright.
We're ready now.
Cotangent of 60. Let's go.
Okay, let's be quiet. All right, I want to go back to cotangent of 0. Tangent of 0 was 0. You look and you see it's the reciprocal of that, so you say undefined. So some of you might have to correct your papers. And for the last 11 minutes, I'm usually not serious, but I really need to be serious and get through this, okay? All right, cotangent of 60. You look up the hang on, I'm gonna write it. Thank you. I'm gonna look up the tangent of 60, which is square root of 3. I'm gonna take the reciprocal of that, which you can leave it like that, or rationalize, I don't care. But you have delta math in your future that does care. When I look at my sine of 270, I get negative 1. Cosecant of 270, therefore, would also be negative 1. The reciprocal of negative 1 is also negative 1. Sine of 300. Ooh, I forgot I let those fly in there. Were those really on your paper?
Yeah.
I'm so sorry.
It's the it's
Raise
the
your hand if you want to answer sine of 300. All right, Alex?
Negative root 3 over 2.
How did you get that, Alex?
I looked online.
So here we go. This is what we're going to do.
Oh, I know.
Hang on, Brand, I'm going to have to keep talking, okay? I'm going to show you how to do it. Girls, this is a lot of your homework right here, okay? What we're going to do now, we're going to venture out of the first quadrant, okay? And I've already done a lot of the teaching of this today, so you'll be okay. We'll write something phenomenal in your chart in just a minute on your memo page that will help you a boatload. I'm going to go over here to 300 degrees. Always make sure your reference angle is part of this bow tie this way. My reference angle is 60 degrees. I'm 60 degrees away from 300. So go to your chart and look up the sine of 60 degrees because all of these numbers are going to be the same. It's just that Bryn and Alex and I have to worry about if it's positive or negative at that moment.
It's square
Do y'all see the 60 degrees? The sine of 60 is square root of 3 over 2. You've not had to worry about anything so far about sines, S-I-G-N-S, because weren't X and Y both positive in all the things I've asked you so far. Sine, I've told you today, is Y over R. What is your Y component in the fourth quadrant? Is negative, so it's negative. Let's do cosine 150. All right, cosine 150. Girls, thank you for playing. I'm going to cosine 150. Raise your hand if you know the reference angle of 150. Dakota?
Be negative 3.
Wait, do you know the reference angle? I think that's what you're doing.
Sorry, yeah.
What are you going to look up? 30. All right, so we got to know that first, but I could tell by her answer she was doing what I needed her to do. So now, are y'all with her? Cosine of 30. So Dakota, I think you're going to tell me square root of 3 over 2.
Yeah. But
And now cosine is x over r. What is x in that quadrant? Is that y is positive, but what is x? No,
Negative 1.
I'm at this 30-degree angle. It's not 0. My x component
Negative
is
1.
negative. The answer is negative square root of 3 over 2.
Is it because it's literally on the line?
Oh, no. I'm going to this point right here.
Wait, but where do you get?
Like, see how I get to this
okay.
point right
Yeah.
here? I'm going to this point right
Yeah.
here, okay? You have an adjacent hypotenuse and a thing.
it's post 30.
Adjacent, opposite.
Then you
Hey girls, if y'all let me keep going, you'll get it. So let me talk for a minute, okay? And then I'll ask you to raise your hand when I want an answer. But if I just keep cranking these out, you'll get it. All right, so tan of 120. I'm going to go to 120 degrees. My reference angle I subtract from 180 and I get 60 degrees. So I go into my 1, 2, 3 chart and I look up tangent of 60, which is square root of 3. Now let's look at our x and y components. Okay? This is x and this is y and this is r. On your memo page the other day or today, you wrote tangent is y over x. To reiterate, wouldn't that still be opposite over adjacent?
Yes.
What is x? Negative. What is y?
Positive.
What's a positive over a negative?
A negative.
So that's negative root 3. Sine of 210. Sorry, all of those, they don't have to end up negative. I'm kind of sorry I gave you those. I'm going to go to 210. My reference angle is 30 degrees. I'm going to look up sine of 30 degrees, and I get 1/2, and my y component is negative 1/2, okay? Now, you're just going to watch me for a minute, and we're going to write something awesome on your memo page to where you don't even have to think that much, okay? All right, so you're just watching. I will step away from this when it's time to write. Okay, in the first quadrant, here's the triangle. What is x and y are both positive to get to this angle, okay? Like you were asking me, Kate. You see what I mean? To get to that angle.
Yeah.
So let's write sine, cosine, and tangent. You're not writing, you're just watching. They would all be positive in the first quadrant. That's why I haven't worried about giving you first quadrant angles until I pushed you further accidentally, but it probably wasn't a bad thing. In the second quadrant, once I get my reference angle, x is negative, y is positive, and what did I tell you the radius would always be? Radius is always positive. It's the radius of the circle.
Oh yeah.
But that's like
It's-
-1.
The radius of the circle. If I said draw me a circle with a radius of 1, you could do it. Could you draw me a circle with a radius of -1?
Oh, no.
So watch that little red second hand.
Yes.
Do you see how that length is never changing? The hypotenuse is always positive because it's just a distance from the origin, okay? So let's do sine, cosine, and tangent. Sine, you just learned today or the other day, is y over r. That's a positive over r is always positive. Cosine is x over r. What kind of distance is that?
Negative.
I'm on like a graph, okay? This is 0, 0. That's positive, so what is this?
Negative.
Negative. So x is negative, x is adjacent over hypotenuse, x over r, so that would be negative. Are y'all okay with that?
Yes.
Negative over a positive. Now what would tangent be? Y over x or opposite over adjacent.
Negative.
A positive over a negative is a negative.
Yes.
In the fourth quadrant, that would be the third quadrant, sorry. X, Y, and R. What are X and Y both now?
Negative.
Negative.
It's gonna make
But was R always? Positive, okay? So sine is Y over R. Cosine is X over R. But what is tangent? Y?
Positive.
Why?
Because they're both.
It's a negative over a negative, so I get a positive. All right, in the fourth quadrant. You know how I did all that 1, 2, 3 stuff, so you don't have to do it again? We're about to have that. It's gonna be great. This is X, Y, and R. Sine is Y over R. What kind of number is that?
Negative.
Negative. Cosine is X over R.
Negative. Oh, just kidding.
Are you okay?
No.
Cosine's adjacent over hypotenuse.
Yes. Oh.
Okay? So it's X is
Oh,
positive.
got it. Okay, I thought.
Tangent, sorry, and the board is getting off.
I thought Y was involved. That's what I said. Negative.
Sine was negative, cosine, cosine's positive, and tangent is Y over X.
So that one's negative.
That one's negative. All right, now I've derived it once and for all. Hope you understood that.
Yes.
Okay? All right, so what I want y'all to notice is in the first quadrant, they are all positive, okay? In the second quadrant, sine is positive. In the third quadrant, tangent's positive. In the fourth quadrant, cosine is positive. So this really cool thing that someone made up that I'll draw on Miss Alvar, okay? That axis looks like a big plus sign, doesn't it?
Yes.
So what I'm about to teach you is what's positive in each quadrant. In the first quadrant, they're all positive. In the second quadrant, only sine is positive. In the fourth quadrant, only tangent is positive. And third quadrant. And in the fourth quadrant, only cosine is positive.
Should read
You
that.
may have heard, not yet, you may have heard this acronym before. If you haven't, here it is. All students take calculus. Now you know all of your signs, okay? So what you'll write on your memo page is all students take calculus. So write that down real quickly. Okay, and yeah, tutors may have given you other ways, so I would just say take what works best for you. Have an open mind. This might be easier, but if it's not, use your own thing, okay?
Thank you.
Okay, I'm gonna start this over here.
Thank you.
All students take calculus.
So it's really
We're
just
gonna go right up to 2 more minutes, so I'm gonna change your homework a bit, okay? Still no quiz on the next class. We're not ready for that yet. But you'll have this worksheet and 1 Delta Math to do. Right now there's about 5 Delta Maths up there that you probably could do, but I pushed you pretty hard on the last stuff, so you'll get practice with this on paper and on Delta Math, okay? All right, so don't pack up. That would make me so mad if I ever got mad. Okay, so here we go. What's number 1 on the sheet? Have your memo page out. What is it, girls? Sine 150. You'll get to where you see the same things over and over again, okay? So I'm going to go to 150. My reference angle is 30, okay? So I'm going to go to sine of 30, and I'm going to lift that out of my 1, 2, 3 chart, which is 1/2. Now for the whole rest of your life,
it stays positive.
just a minute, Rihanna. For the whole rest of your life, you will never pull something out of that 1, 2, 3 chart without checking all students take calculus. Those have to go together, okay? You didn't know it, but you were already doing that. It's just that all of your ones so far until the last few problems were in the first quadrant, okay? So as you pull this out, what is sine in the second quadrant? Watch this. All students
Positive.
is positive. Done. What's number 2?
Cosine 180.
Cosine
180.
180. All right, well, I don't even have any reference angle there. I just look at my IOU chart. It's -1. Cosine 180 landed right there.
Yeah.
That's in your IOU chart. Next,
Tan 390.
390. Okay, so I'm going to rotate around 360 and then it goes a little more. How much more? 30 degrees more. Tangent of 30 is square root of 3/3. All students is positive. So you see how you do both of those, okay? And the Delta Math, the nice thing is you can check that, okay? You can also check these. You'll get decimals on your calculator. Don't check them on your calculator. That can be confusing right now. I just wouldn't suggest doing that. Okay, so your homework will be to finish this worksheet and to do 1 Delta Math. So I'm going to sit down right now and get rid of all the other Delta Maths I had piled on top of you, okay? And then also, I think at this moment, you can start packing up now. At this moment, getting up and leaving. I think right now it says quiz. If you've already read the assignment, make sure you hit refresh because you do not have a quiz in the next class. But you will in the next class after that, okay?
Yeah.
All right.
Thank you.
Thanks, girls.
See you tomorrow.
Okay.
All right.
Oh,